Hello, this is Curtis Goodwin. This is my final project for ADTA 5240, Harvesting, Storing, and Retrieving Data. Part 1 of the project will include a strategy to deploy big data technology at Charles Schwab. There's 5 components in this strategy. The first, I want to take you through an overview of Charles Schwab, what services it provides, its competitors, the size of the company, and all factors that determine what type of technology will be effective. The second will be big data technology itself and the components planned for deployment within the company, their purposes, and why they're going to provide an advantage. The third component will be any department additions and the roles within those departments. Anytime you add big data technology, something new to a company, there will be new, highly skilled workers that will need to be employed to leverage actionable insights. The fourth component will be human, intellectual, and capital. This will talk about the investment it will take to ensure that all employees currently working at Schwab will be trained with the necessary tools for big data for the roles that they're in and so that they can be successful and use the technology to make better decisions and provide better services. The last thing is we'll wrap up with a conclusion that kind of summarizes the key points. So let's start with an overview of Charles Schwab. It was founded in 1971 as a saving and loan holding company. It's currently a public trading investment firm, and its current shareholder price is $37.28 on the New York Stock Exchange. They are building a new headquarters campus in Westlake, Texas, and they're expanding their operations and planning to employ 4,000 new employees. Their current state, they are a Fortune 500 company. They employ 19,169 employees with 12 million active brokerage accounts with over 3.7 trillion in client assets. There are 4 main sections of services provided. Each main section has a bundle of products offered to consumers. Consumers can be individual consumers or business consumers. Their diverse portfolio of services provided expanded a list of competitors as they do not focus on one financial product. Some of their main competitors in the market include Fidelity, Goldman Sachs, TD Ameritrade, Morgan Stanley, Ally Financial, and E-Trade. There are many more, but their competitors are diverse because their products are diverse. For example, Fidelity Investments, they are competing with low-cost ETFs, whereas Goldman Sachs, they compete mainly with security brokerages. Some of the current news about what's going on in Charles Schwab include their new Westlake campus that we talked about. That's going to bring about 4,000 new jobs to the North Texas area. Schwab is also currently negotiating a deal to buy USAA wealth management and brokerage units. This move speaks to Schwab's willingness to expand its business, partner with other companies, and continue to evolve in the industry. The newest business policy that's come out is eliminating trading fees, and it's sort of been a war with ETFs between themselves, Fidelity, and other financial firms that offer ETFs. ETFs are exchange-traded funds where they invest in a collection of securities like stocks, bonds, and other things that track an underlying index, such as the S&P 500. The benefit of an ETF is that it's diverse compared to buying one stock, and you can reap benefits of a diverse portfolio without the expense of putting one together with a financial advisor. Many ETFs are automated, and because they're automated, the company still makes money off commission and trading fees. However, Schwab was one of the cutting-edge businesses that have eliminated the trading commission to entice customers to buy more ETF products. So what is the big data technology plan that's going to improve business decisions and overall products at Charles Schwab? Well, the first thing is we want to use Google Cloud Platform. Google Cloud Platform is a high-powered cluster computing platform that can house different ecosystems. The next 2 things that will be deployed are the Apache Hadoop ecosystem, utilizing mainly HDFS, MapReduce and Yarn, and Hive 2.0. We'll also deploy Apache Spark Core in conjunction with the Hadoop ecosystem. And main parts of the core would be Spark SQL, Spark Streaming, the machine learning library, and GraphX. So Google Cloud Platform, what does this bring to the company that will give it an advantage? Well, Google Cloud Platform has high quality security, and with sensitive information such as financial services, what's called Google grade security will be employed through the cloud services. It's also economically cost effective. Google's come out with billing by the second. That means when we're not computing or using it, we can shut down the cluster and we're not charged for it. It allows for big data, cloud computing. That means that everything we do will be scalable to the size that we need as we expand our company. And it's also environmentally friendly, which customers may like. It runs on half the energy of competitors, and when available, is 100% renewable energy. You can see that IT managers, which platform they prefer, and Google Cloud is at the top. So the main Hadoop ecosystem components will include HDFS, MapReduce and Yarn, and Hive 2.0. And we want to talk a little bit right now about Hive is going to run on top of HDFS and MapReduce, and why that's going to be an effective subsystem that our analysts are going to use in Charles Schwab. So to look at the process of how a query works in Hive and why this will be effective in cloud computing and big data, we want to understand the process of Hive. So if the user gives Hive a query to process, the query command enters the Hive server to be processed. MapReduce then works with Hive, takes the command, and maps the process to break up one big task into smaller tasks, then processes the smaller tasks with the data nodes in HDFS, and returns the execution of the query into Hive to output the request. The loop of moving information from Hive server to MapReduce into HDFS and then back takes time, but it is cost effective. It's a good system when time constraints are not tight or analysis is not needed to be in real time. In contrast, Spark SQL out of Spark Core works much faster than Hive. But to understand this, we want to understand the process of Spark SQL. Therefore, when a query is entered for Spark SQL, Spark SQL has access to Hive Metastore. And that's really important because the two work in conjunction with each other. And that's why we want to deploy both here at Charles Schwab. So Spark SQL takes the query request, accesses Hive Metastore, uses the data it needs, and then processes the request using in-memory RAM processing. This skips the loop that Hive uses with MapReduce and HDFS. This also requires high computing power to process large volumes of data without breaking down tasks into smaller ones. Spark SQL also converts data in queries to RDD, or Resilient Distributed Data Sets. RDD concept allows for semi-structured and unstructured data to be logically distributed as a structured data frame, and it's going to give analysts an ability to interact with more data types that are collected. Spark SQL is a great option for tight time constraints or anything that needs real-time analysis. So why use the two? Both have advantages to the company, and so employing both gives our analysts, business analysts, financial analysts, and then also our data scientists the option of which one to use based on the situation. Hive is great as a cost-effective tool, creating tables, accessing large amounts of data, particularly in like a data lake, and then also it's good for analysis with historical data. The Hive language, HQL, is very similar to SQL, which would not require any additional training. The familiarity would be there for our analysts. Spark SQL, that advantage is it has faster performing computer speeds. Its access to Hive Metastore for existing tables would not mean you need to reduplicate work in Spark that you haven't already done in Hive. It provides real-time analysis, interacts with other components of Spark Core, and the SQL language is almost exact to the SQL language that business analysts use on a daily basis. So again, whether they use Hive or Spark SQL, there would not need to be additional training to learn a new programming language. The next subsystem of Spark Core that will be employed at Charles Schwab is the machine learning library. The advantages of this, one of the advantages, is that it interacts and reads with multiple programming languages, meaning our data scientists will not have to learn a new language that they don't know just to use machine learning library. It supports Python, Java, Scala. It was written in Scala. It also supports R, which is a statistical programming language. If there is a team project with our data scientists, we may ask that everything be done in one uniform language, just for the familiarity of the team. But this also allows for individuality while using machine learning library. Spark's machine learning library also comes with preloaded machine learning algorithms, classification, regression, clustering, and other statistic tools that you can see in the picture to the right. So what these do is they allow our data scientists to not have to recreate every single machine learning algorithm out there. So for a basic example, if we need a regression model, say a linear or logistic regression model, those are pre-coded in and we can accelerate our work time. It also uses Spark Streaming for real-time analysis. It's scalable with large volumes of data, and it interacts with other components of Spark Core to update the model as data is updated. The next component of technology we're going to use is a visual tool, Microsoft Power BI. You've heard the saying, a picture is worth 1,000 words, and so we want a visual tool that tells a story of our big data and how we're using it. So the advantages of Microsoft Power BI is it's cost effective. It's got the same functionality of Tableau, but at a cheaper cost. It also provides a variety of visuals available, and we're able to update those visuals with new data, meaning that it's scalable, and it provides options to our analysts so that they can kind of customize the package of how they want to display that story of our data to the customers. The final piece in technology that we want to deploy at Charles Schwab would be an app development team. We've used great technology to produce great products with big data so far, and now we want to wrap that insight into something that's consumable. Everybody utilizes smartphones, and so we can use that as a communication tool for some of the insights that we have, both for our employees and then also our customers. It's user-friendly and it would be cost-effective. The app development team would be a great avenue in which we could productionalize the insights that we're finding with all these other tools for big data and actually put out better products, making better decisions. So now that we've implemented our technology, we need to implement some new departments and roles that are going to help utilize this technology properly. The first department would be a business intelligence advanced analytics group. They would work on operations research throughout the company, solving real business problems. These problems would be related to risk, revenue, operations, and big concept problems using the big data and the technology as parameters to provide real solutions to our different business units. The second department would wrap around machine learning and simulation. This is where we'd house our data scientists. They'd work with model development and real-time analysis and prediction for our products. The third department would be artificial intelligence and research and design. We want to stay on the cutting edge of technology, and so this department would be committed to developing deep learning and AI within fintech, financial technology, and they would propose areas within the Schwab operations where we can implement AI for advantages. The human intellectual capital is the investment we make to our employees to make sure that they're well trained for this technology coming in. For the whole firm, we want familiarity with big data technology. That's interaction, the interpretation of results, and the use of visualization. Our financial analysts, we want to train them in Google Cloud Platform, make sure they have an understanding of HiveQL and SparkQL, which is familiar to them, and then also how to leverage Microsoft Power BI for their customers. Our data scientists, we want to make sure that they're trained with the most cutting-edge techniques in the industry. We can use online training platforms as well as interdepartmental trainings. In conclusion, Charles Schwab is a large, diverse company that can use Apache Spark, Apache Hadoop, Microsoft Power BI, and app development with technology to deal with big data, to leverage big data for competitive advantage.